All right, in today's video, we're going to be talking about the law of cosine, section 6.2. At this stage, I'm hoping that you're an expert at the law of sines. All right, so as a warm up today, let's take a look at the following problem, and I would like you to explain why the law of sines is not going to help me very much with this triangle. First of all, we don't know if it's a right triangle or not. It's just a random triangle. In fact, we could confirm that it's not a right triangle, presumably by doing the Pythagorean theorem to see if it actually works, which it most likely is not. So let's assume that it is not a right triangle. And therefore, if I was going to try to use the law of sines, then I could write the sine of A over 7.9 equals the sine of B over 3.5. And you can clearly see I do not have enough information in order to successfully solve for one of the missing variables. Tacking on the other one doesn't do me any good because I do not have a ratio established. I do not know how to solve this. So the law of sines is limited. And so what we're going to talk about today is the law of cosines. The law of cosines is going to help us with this scenario. All right, so first thing I'm going to do is I'm going to just give you the law of cosines. So there are three versions of the law of cosines, but with quick inspection, you will see that really it's just one version. They're all just really saying exactly the same thing, and I'll talk more about that eventually. The one thing to point out is that we have the side A, and then we have cosine of A. We have little side B and cosine B, and the same for the C's. And then all the other variables are the other two side lengths, right? So you've got the B, the C, and the B and C again. We've got the B by itself over here. We've got the A's and C's, etc. All right. So where does this come from? Well, we're going to do a little bit of an algebra exercise here to figure out why the law of cosines is what it is. And so we're going to use this triangle I've created on the right side of the screen. And I have dropped an altitude labeled H down the middle. And so looking at this triangle, I can kind of start talking about the various parts. So when you're trying to derive a formula for something, I mean, really what we're going to do is we're just going to use known math here. So I'm going to focus on triangle 1, which I'm going to call this little triangle. So number 1 is going to be this little triangle, and number 2 will be this triangle. So one thing I could do is I could write the Pythagorean theorem. Okay. Before we continue, I guess I should point out that the whole length of this AC side, of course, we know is B. And what I've done when I drop the altitude down, it's intersected at a point where I don't know. So I have arbitrarily said that it's X units away from A, and then that would leave the distance remaining as the whole distance B minus X. So in that way, I can kind of talk about each individual side length. All right, so with that established, I can talk about triangle 1. I know that the leg squared, so x squared plus h squared would have to equal c squared. And then triangle 2, I could say that h squared plus b minus x, the quantity squared, has to equal a squared. All right. I'm going to probably FOIL out the second triangle. So I have h squared plus b squared minus 2bx plus x squared equals a squared. And then I'm going to look at this problem, and I'm going to notice the x's, I think. Do I want to focus on the x? Let's take a look. I could look at the h's. I could look at the x's. So I want to eliminate some variables. I got way too many variables in this situation. And so let's go ahead and eliminate, we may erase and back up, but let's eliminate the x's. So what I mean by that is if we go ahead and call this x squared equals c squared minus h squared, then I can come over to the other triangle and do a substitution. And I can plug in that into x squared. And I'm not 100% sure this is where I want to go with this, but let's play it out and see where we get. So I get h squared plus b squared minus 2bx plus, now x squared is c squared minus h squared equals a squared. So I've done a substitution. And let's see what that does for us. Let's go ahead and multiply out our math here. Actually, I guess remove our parentheses. So h squared plus b squared minus 2bx plus c squared minus h squared equals a squared. And I like my choice here because now my h squareds are gone and I no longer have any h's in the equation. So now I'm down to b squared minus 2bx plus c squared equals a squared. All right, so I'm feeling pretty good about this, but there is still a variable that's sort of artificially in the equation that I'd like to remove, and that, of course, would be this x value. So I would like to do another substitution, just like I did with my x's, my x squareds, right? I was able to take those out of the problem. So I could do something kind of crazy, like take the square root of x squared, right? And then that would tell me what x equals. But then what I'm going to do is I'm just going to trade one variable for another because you'll notice this is defined in terms of h. So if I replace with x with this, now there's no x's, but I've introduced h's and, frankly, an ugly square root. So let's find another way, if possible, to remove that x. So I'm going to go back and look at my problem. And I'm looking here at this triangle, and I'm seeing the x, and I'm seeing the c and the h, and I'm noticing that if I did the cosine of a, so I could write the cosine of a is equal to x over c. I wouldn't want to use the tangent because that would include the h and the x. And again, my goal here is just to remove all these fake variables I plugged in and just have the a's, b's, and c's. So using cosine here relates my x and c together. So then I know that x is equal to c, little c, cosine of a, which allows me to do another substitution where I can plug this in for my x value. So now I have b squared minus 2 times b times c cosine of a plus c squared equals a squared. A little bit of minor rearranging. I'm just going to move the a squared to the other side. Just going to flop the equal signs here. And then I'm going to put the b squared, and I'm going to move the c squared up next, minus 2bc cosine of a. And you will notice, especially if I zoom out here, that is one of the versions, in fact, it's the top version of the law of cosines. Okay, so that's the first version. Now, I'm not going to show you the others because all it would require me to do is draw my h from a different vertex, right? I would drop the h maybe from A or from C and then repeat all the math we just did, and it would generate the other two parts of the law of cosines. So with the law of cosines, you'll notice there are A, B, C, that's 3 variables. There are 4 variables. So assuming you have one unknown variable, this really requires us to have 3 known parts, which I guess is true of the law of sines as well. All right, so how is this going to help me? Well, let's take a look now. Example 1, find the angle measurements of the triangle from the warm-up, okay? So I'm going to go back up to warm-up, and I think I'll erase this. And now what we're going to do is we're going to do the law of cosines. Now, when I do this, a law of cosines is often, depending on what you're looking for, is often followed up by a law of sines. So thinking through the whole ambiguous case situation, it would be really handy if I just found if I have the option, if I use the law of cosines to find the biggest possible angle. So in this situation right now, since I could find either A, B, or C to start, it's my choice. So I'm going to find angle A. So that means I'm going to use the version of the law of cosines that has angle A in it. And that would be the first one. So then this is a really easy thing to memorize. It's basically kind of like the Pythagorean theorem, right? It almost looks like a squared equals b squared plus c squared, right? It's basically the Pythagorean theorem. And then this extra piece. So what's this going to look like? It's going to be 7.9 squared equals the other two. So it doesn't even really matter which one you put first. The 7.9 is the one out here. That's my A. And then notice it's b squared plus c squared. That's just the other two, and they're added. And you can add in any order. So honestly, it really doesn't matter. So we're going to have the 3.5 squared and the 5.1 squared. Then it's minus 2 times, and then just those two numbers multiplied. So once again, it doesn't even really matter which one's which, as long as you have it straight that the 7.9 is the one opposite the angle you're looking for. So I got 2BC, and then I just have the cosine of A, which I do not know. So now it's just a matter of just not screwing up the math. And hopefully we can see that this is all one big term right here. And don't do something silly like try to add all this stuff to one of these. This is being multiplied by cosine A, so this is eventually going to require a division. But let's clean up some numbers here. So let's turn Mr. Calculator on. So 7.9 squared. So that's 62.41 equals 3.5 squared. 12.25 plus 5.1 squared is 26.01 minus 2 times 3.5 times 5.1 is 35.7 times the cosine of A. So now it's just a matter of either combining the 12 and the 26 and then moving them over, or moving them over individually. It doesn't really matter. But that should give us 62.41 minus 12.25 minus 26.01. So that gives me 24.15, as long as I didn't hit a wrong key, equals negative 35.7 cosine of A. So now I just need to divide the 2415, which is still on my calculator, by the negative 35.7. And I get negative 0.67647 and some change, approximately equal to the cosine of A. All right, I should not be at all concerned with the negative number. because I was expecting a negative number, if you think about it, because we looks like if the drawing is at all accurate, we're looking for an obtuse angle. So drawn in standard position, that would be an angle in quadrant 2 on a unit circle. And we know that the cosine would be negative in quadrant 2. So when I do the arc cosine here, so arc cosine of my answer, I get angle A is approximately equal to 132.568 degrees. You will notice we have no worries of an ambiguous situation with the law of cosines because there are not two angles that have the same cosine between 0 and 180. 0 to 90, the cosine is positive, and 90 to 180, the cosine would be negative. So we'll never have a situation with law of cosines where it's like, oh, is it this or the supplement, like we do with the law of sines? Which is why I used the law of cosine, since I had a choice, to find the biggest possible angle. All right, so now I know A. Now I need to find B or C. So you have a choice. You could either go again to find B or C, because I have my choice, because I know all the opposite sides. Or I could switch to the law of sines. If at this point you switch to the law of sines and you still aren't sure, like maybe you haven't found an obtuse angle yet, then just choose your law of sines carefully to find the smallest remaining angle. So which one's going to be the smallest remaining angle? Well, I just found angle A. And so between the two remaining angles, I've got B and I've got C. So again, it doesn't matter in this case because I know both of those answers are going to have to be acute. But let's pretend like I wasn't paying attention to that. Then the smart play would be to find the one opposite the smallest side. So I'm going to find B. So I'm just going to now write the sine of B over 3.5 equals now my known set, which is A. So sine of 132.568. And again, ideally, we use more decimal places, which is still sitting on my calculator, divided by the opposite side, which is 7.9. And so, to answer my question, I'm just going to take the sine of the angle I just found, 132, and divide by 7.9, and multiply by 3.5. So I know that the sine of B equals 0.32628 and some change. So B is approximately equal to second function arc sine of the answer. And I get approximately 19.043. And here again is where, if you're not paying attention, but suddenly you decide to, you're like, oh, wait, also 160-ish would have the same sign, the supplement of 19. But since I already know A is obtuse, then clearly B can't be obtuse also. So now I know that B is definitely this, A is definitely this, so then C would simply equal 180 minus B and minus A. In other words, add those two together and subtract. So if I did that very quickly, I've got my 19. I'll add my 132.568 and then subtract 180. And again, I'm ignoring the negative because I know I did that backwards. So then C equals, approximately equals 28.389 degrees. All right, got a little messy there at the end, but I think you can all see how this worked. All right, let's now look at a more common situation. More common meaning oftentimes we're not going to know all three sides. Sometimes, like example 2, we're only going to know maybe two sides. All right, so let's draw a triangle. And I don't know, I'm not going to overthink it. I'm just going to draw a triangle. For all I know, it could be an obtuse angle and it could be crazy different from my picture, but I'm going to roll with it. All right, I'm going to call this angle A, and this would be 21.26. And side B, I'll call this angle B. I'll call this angle C. C is 25.25 degrees, and this is 15. All right, so I don't know little c, and I don't know angles A and B. Law of sines will not work because the side I'm missing is opposite the angle I know, so that does not help me. I don't know the other two angles, and so using law of sines is out of the question. So I'm going to have to use law of cosines. So the law of cosines, I'm going to, again, it doesn't really matter what's called A, B, and C. It really has to do with what angle are you choosing to use, and then making sure you place the opposite side and the other sides where they go. So this should simply be c squared equals the other two sides, 15 squared, plus 21.26 squared, minus 2 times those two sides, A and B. So again, it doesn't really even matter which one's which. We just multiply. So it's A squared plus B squared minus 2AB cosine of the side or the angle opposite the side C. So 25.25 degrees. So this time the unknown is a side length, and so all my math already exists on the other side. Just pay attention that you have three terms. You've got term 1, term 2, and then a giant term 3, and just don't screw up your order of operations. So c squared is approximately going to be equal to, let's see, 15 squared. I knew the answer. I don't know why I did that. Plus, I don't know this one, 451.9876 minus, let's see, 30, 2 times 15, so 30 times 12.26. But we might as well go ahead and multiply by the cosine of 25.25. So that's 332.658. 659, I guess. And now what am I going to do? I need to combine all this together. So I'm going to kind of do things a little bit backwards here. I guess I'll call this a negative number. I'll go ahead and just convert it. So now I can add 451.9876, which I think was an exact number. So there's no rounding issues other than this one right here. And then plus 225. So I look to have c squared is approximately equal to 344.32899975, or little c is approximately equal to the square root of that number, which is approximately 18.556. All right, so little c, let's document it. 18.556 5, 5, 6. What else do I need? I've got little a, little b, little c. I've got big C. I need big A. And I need big B. All right. So now I need to either redo this. I can redo law of cosines, which I don't want to do because it's a lot more math. So I'm going to use the law of sines, but I'm going to be smart about this. I need to find angle B and angle A. I can clearly see, based on the opposite side length, that A is going to be my biggest. Not because of my drawing, because my drawing could be crap. I'm paying attention to the side lengths. So I don't know if any of these angles are going to be obtuse or not, but if there's going to be one that's obtuse, it's going to be angle A. So that means I'm going to focus on angle B with my law of sines, because then I can trust what the calculator gives me for the arcsine. I don't have to worry about the supplement. Let's see it in action. So I'm going to do the sine of B over 15 equals now my known pairing of the C's. So the sine of 25.25 degrees over, as if I can help it, again, the most accurate version of this. So 18.556, and I've still got on my calculator 10405. Okay, so then that means the sine of B is going to equal the sine of 2525 over 18.556, 10405 times 15. All right, so seeing this in action, I'm super lazy. I don't want to retype this number that's sitting on my calculator right here. And so what I'm going to do is I'm going to divide the wrong way. So I'm going to divide by the sine of 252. Nope, that's a lie. Back up. 225.25. Okay, so when I hit enter, that is the wrong answer, but it is the reciprocal of the answer I want. So I'm going to simply hit the x to the negative 1 button and flip it over. So that's what I get when I do the sine of 25 divided by 18. But I still need to multiply by 15. Okay, so let me give myself some room to work here. So now I'm left with the sine of B is approximately equal to 0.34482 and some change. And so I'm going to find the arcsine of that number. So the arcsine is 20.1708. And I know, because I found the smallest angle remaining, I found angle B, which is opposite 15. I know this has to be the 20. Because if it's not the 20, it's 160. And we know it can't be 160 because angle A has to be bigger because it's opposite 21, but also because 160 plus 25 is too big. So I'm confident I have my answer for angle B, 20.171 degrees. And now I can get angle A just subtracting from 180. So 20 plus the 25.25, and then subtract from 180, and I get approximately 135.579. And last check I'm going to do, my biggest angle, 135, is opposite my biggest side. My next biggest angle is going to be C, opposite my 18, and then the 15 and the 20. Okay. So if I had found A first, right, if I had done the sine of A at this stage, then there is a strong potential I get the wrong answer, because there is only one right answer here. But if I had found the big angle and called it the acute angle without paying attention, then everything would have been thrown off. All right, let's take a look at a story problem and we'll call it a day. All right, a ship travels 60 miles due east. All right, so I know where I'm going to start. I'm going to start here and we're going to travel 60 east. So I'm going to go directly east for 60 miles. At point B, it adjusts course. So let's call this point B. And we're going to adjust course, and it doesn't tell me specifically, but a northeasterly direction. So northeasterly, let's go ahead and make a compass rose. So I'm trying to be very straight and organized here. And again, I have no idea the angle, but north and east. So I'm going to come out here. And we travel for 80 miles. And we arrive at point C. The ship is 139 miles from its departure point A. What is the bearing the ship took when traveling from point B to point C? So before I even think about doing any math, I'm going to try to figure out, like draw in that angle. So we know that bearing is measured from either north or south, and it's an angle between 0 and 90 degrees. So it looks to me like my answer should be this red arc right here. And therefore, I already know my answer is north something east, which makes sense anyway because it was a northeasterly direction. So what I need to do is figure out what that angle is. So if I can find, let's see here, if I can find the entire angle, and then I can subtract 90 degrees from it, I'll have that red arc. So the question is, do I have what I need to just directly find the green answer? And the answer is yes, I do, because I have the 3 side lengths, and so that means I can use the law of cosines. So I'm not even thinking about the A, B's, and C's. What I'm thinking about is the opposite side to the angle I'm talking about. So I'm just going to write it out. It would be the opposite side, 139 squared, equals the other 2 side lengths, 60 squared plus 80 squared, minus 2 times 60 and 80. And then I'm looking for the cosine of theta, or we'll just call it B. But again, notice we don't get too hung up on what side is what, because multiplication and addition you can do in opposite order or in any order. All we have to do is make sure we get this side and the angle that's opposite in those 2 locations. So once again, this is going to require division, so just don't screw up your math. I don't need you to show me every little step, but also don't do everything in your calculator. So here's what I mean. I'm not going to type everything in my calculator and say go. I'm going to do things a little bit at a time. So I can already see I'm going to subtract this, I'm going to subtract that, and then I'm going to divide by that. So let's just do that on our calculator. 139 squared, and then I'm going to subtract 60 squared, and I'm going to subtract 80 squared, and then I'm going to divide by, and here's where we cannot screw up if we're going to do this. When we divide, we're dividing by all of this stuff. And so it's going to be a negative number, which usually I wouldn't type in my calculator. I would just make it negative at the end. So I'm going to skip the negative. So I'm going to divide by, in parentheses, or you know what I would really do if I'm really doing this for myself? I would divide by each piece at a time. So I would divide by 2. I would divide by 60. And I would then divide by 80. And so now I'm left with the cosine of B equals, and again, a negative number because of this negative right here, It'd be negative 0.97093. So then therefore B is approximately equal to, now before I go ahead and do the cosine, I need to make sure I make this a negative number. So I could do one of two things. I could just hit the negative option or just multiply by -1. And then I'm going to take the arc cosine. So the inverse cosine of my answer, and I get approximately 166.1528. That is not my answer. That is the full angle B. So according to my picture, I want this little red bearing, which now would be -90. So that would be 76.153 degrees. All right. So hopefully you can see how the law of cosines and the law of sines work together. When you're dead in the water, you can use the law of cosines. When you have the choice, use law of sines. The math is quicker and easier. All right. Notice on this question, I had a good plan here and I was paying attention as I go. If you are not very good at paying attention to details or you're distracted when doing your math, I would encourage you to write more things down and do little steps at a time instead of doing it all together like you saw me do. All right. Hopefully this makes sense, and we'll talk in class.